I wanted to record a quick instructor run through for the population ecology survivorship lab for BIO113. Um, all the information you need is really in the handout, and there's not that much. So essentially, what you're doing is you're introducing survivorship curves. These are the curves, and then with the simulations you do, there's three of them. You're trying to basically recreate each of those curves. Um, Survivorship curves 1, 2, and 3. The dice simulation, the first one, is the dice simulation where you're removing all of the ones, and in that case, that is your number 2. In the second population, you're removing the ones and twos, and I'll explain in detail exactly what you do there um, when I get to the charts that the students fill out. So you're going to remove the ones and the twos. Those are going to be number 3. And the soap bubble simulation, you're going to simulate parental care, which is your number 1, your curve number 1. And the things the students fill out is this population data, number 1 and number 2 of the dice, and the bubble population data. And then they're going to graph this on semi-log paper. So the task, and then they're going to explain which curve is which that they just graphed. So they graph all 3 curves on the same piece of paper. And hopefully they'll have something resembling a type 1, something resembling type 2, and something resembling type 3, and they recognize that they do. So that's the big picture. Now, the way I approach this when I do this, I actually approach this with a PowerPoint. So we start them out with a couple of definitions. I talk about this is what a population is because the word comes up and it means something in biology. Oftentimes I talk about the fact that words mean something in biology and that you have to use them correctly. That's part of how biology works. And then survivorship, and I talk about why we're counting the survivors rather than counting the dead ones. Um, then I introduce survivorship curves, and I remind them that, how do you remember type 1, type 2, type 3? Well, because humans were number 1. That's the type 1 for us. Then I have them practice using these pictures, and we talk some more about, what makes type 1, what makes type 2, and, what's kind of a in between where it's a little difficult sometimes to decide which one it is. Then I want to tell them a little bit about exponential growth and why this is. We're going to have to deal with this problem um, of semi-log paper because that's the next thing we're going to be looking at. And so I tell the story of the rice and the chessboard problem and the legend that goes along with it. And we talk about how big these numbers get. I talk about bacteria because that's why we really care as scientists. And I mention pyramid schemes because, they're there. Um, then I talk about the graphing problem that goes along with that, with being able to see both the small and the large numbers. And the solution of the graphing problems is a change in the y-axis. So there's no difference in the data, it's just a change in the axis. And then I talk about bacterial growth. I check to see if anybody's heard of bacterial growth curves, the lag, the log, the stationary, that kind of thing. Um, and then the steepness of the curve, that tells you something about how fast this goes. Um, and then in the olden days, I used to just tell them about how to use semi-log paper at this point. Um, Nowadays, I jump back to COVID and show them pictures of how COVID, how the graph was, right, where we had the logarithmic growth in the straight line. Then we talk about how to label the graph paper. So this time, one of the things I did this time that I think worked out really well, and I think better than it did in times before, um, was that I had them label the graph paper before we ever got to the experiment. I handed each of them a piece of graph paper into their hands, um, and said, "Now we're going to label this together." Now, when I ask them to label this, I usually help them. I usually help them find the cycles first, how many cycles they have. And this time it was interesting because the paper we had in the lab had 5 cycles. So there was a little extra challenge that got thrown in there, which was fun. I think it was actually good that it was different because it made them look, right. Um, and so they look for the cycles first. I have them mark the cycles because I say if you're trying to look at this, you're going to go cross-eyed. Um, and then I talk them through the labeling. So first I have them label the cycles in multiples of 10, and then we talk through what's between those different numbers. Like, what's between 1 and 10, what's between 10 and 100, and then I have them literally label all of those. And then because in the past, getting them to start the curve, they don't even know how to start. And so the thing I did right this time around is I literally had them start together. We're like, everybody, where is your first dot that you're going to make? And then we discovered together. So first we labeled the x-axis together, and then we discovered together that the first dot we're going to make is going to be in the top left because we're going to start with 100% survivors at time point 0. And then we're going to make our way to the right, and it always will go down, right? People will ask, why? Oh, mine are going up. They messed something up, right? And then I had them do, so then after we labeled the chart, after we labeled the paper, I showed them how to do the experiment. So I literally had the bucket of dice in front of me and turned it over and said, "This is what you do," and physically pulled out the dice, physically wrote the numbers on the board that I was looking at, um, and then did it 2 times, and then sent them on their way and had them said, "You do the same thing." Um, so everybody did the numbers, and about as I was noticing that most people were sort of done with at least one of them, I stopped them all and asked them to now calculate the percentages, which of course are easy because they're just multiplied by 2. Some of them still overcomplicated things. I'm not good at percentages. This is what they do. Um, and then I had them do basically the whole dice experiment, like completed in its entirety. And when people were sort of done with the second one, um, I had them graph it. I was checking graphs as I was walking around. And as people were sort of done with the second one, some, obviously there's some groups that are faster, some groups that are not so fast. I said, you can still finish, but I'm gonna start explaining what you're gonna do next, so that we get finished at some point. And so, but I made sure that every group had at least one of the experiments completely done. So I made sure that at least population 1 was completely done with numbers, percentages, and a graph. And they were only potentially still, tweaking population 2, what they were doing. So at that point, I explained what to do with the soap bubble population. And so there you blow the bubbles, and then you mark when the bubble dies. So a bubble dies at 2 seconds, one bubble dies at 7 seconds, and one bubble dies at 15 seconds. You're going to make a mark at 2, at 7, and at 15. Then you blow bubbles again. This time you have 3 of them that show up again. You've got one dies at 1, one dies at 6, one dies at 13. So you make a mark at 1, one at 6, one at 13. And you do that for 50 bubbles. Then you transfer the number of marks over here. Start with 50 again, deduct the numbers of 50, and all of a sudden, and multiply for the percentage, and then you have the same numbers that you have comparable numbers that you've created for the dice. Um, some of them live longer than 25 seconds. That's good. They just go out how far out they need to go. Um, and that's the extent of it. I have them turn in a quiz that basically talks about, K-type, R-type selection, strategies of survivorship, examples, one or the other. Um, Recognizing, what number would, like, if this is 100, then what's this kind of thing on the semi-log paper. That's the kind of thing I ask about in the quizzes. And then I have them turn in the sheet from the lab, both the graph and the data. That's pretty much this lab. And it's a lot of fun. There's a lot of laughter as they're chasing around bubbles. And